Hi friends, welcome to this video. So the question is, the following equation shows a method used in the concentration of ore of aluminum. So this is the aluminum ore, that is Al2O3, that is bauxite ore. We treat with NaOH, it forms this salt, followed by excess of water, it forms aluminum OH thrice, which will be white gelatinous PPT. And if we heat it again, we'll get this oxide ore in which impurities are absent, because here along with that some stones, everything will be there, right? Those impurities will be removed because this NaOH only reacts with this bauxite ore, not the impurity like dust. It doesn't react, so dust remains as it is. Later on we'll get a pure ore. So this is the reaction they have given it. It represents, they have given options A, B, C and D. We have to correct the thing, right? So if you have studied this chapter, general principles and processes of extraction of this elements, that is metallurgy, you can easily take this answer, right? But before giving the direct answer, let me explain some things here. So see, first let us talk about this gravity process. What is this gravity process? Gravity process, all these four processes are there, right? All these four processes we call them as what? Ore beneficiation, because here along with ore there will be dust particles through these four methods. That is, one is gravity separation, or second one is magnetic separation, or third one is froath flotation, and the fourth one is leaching. With respect to the ore, we do such processes to get the pure ore, and this dust particle will be removed out. So this process we call it as ore beneficiation, right? Or concentration of ore, we call it as concentration of ore. But we should understand that within this four process, which one we use, right? So gravity separation. First let us talk about this gravity separation. Gravity separation or gravity process is used for oxides ores. Is used for what? Oxides ores. First process. Second thing is, there should be, ore should be denser, means ore should be heavy, and gauge particles means dust particles should be light. Then only we can separate through this gravity separation. Here we use water, hydraulic washing method also we call it as. Gravity process is also called as what? Hydraulic washing method. Hydraulic washing process, right? Because here what we do, here we will have a container and we supply water. With high pressure we supply water, because of which initially ores and dust everything goes up. Later on, as the ore particles have heavier, they settle down here, ore particles settle down here, and the gauge particles will be removed out like this. Gauge particles will be removed out from this. So this is how gravity separation works. So it is done for oxides ore, and here the main principle is ore should be heavy and dust particles, that is gauge particles, should be light. And here we do hydraulic washing method. So that is about gravity separation, right? And coming to froath flotation, second process, that is froath flotation process, is done for sulfide ores. Here what we add, here along with ores are there, sulfide ores, we add some oil particles which contains some fatty acids only. Oils are nothing but what? Fatty acids, like pine oil, other things we add. And we like, see, here container will be there, ore particles will be there, here we add fatty acid, along with that water will be there, and here we will have a thing which rotates like this. Let me change the color of the pen so that you will be clearly understanding. So here there will be like fan like thing will be there. Here we supply air and we rotate it, because of which there will be formation of froath like this, formation of froath. And the principle here is, these sulfide ores are there, right? Sulfide ores are coming with the froath, froath, because these are wetted by oil, whereas gauge particles will be there, right? Gauge means any dust particles, they will be wetted by water. So since these are wetted by water, dust particles, they settle down here, whereas this froath, that is sulfide ores which are wetted by oil, will come with this this one foam, right? Froath, and it will be taken out here as it comes up, as froath floats on the liquid mixture here. So this, the name is froath floatation. So this will be skimmed out, and it will be, and this froth contains what? Sulfide ore, right? Like sulfide source will be there, and it will be kept for drying in the sunlight. Drying in the sunlight, because of which all this froth will go and will get a pure ore particles, and dust particles will remain here only, because these dust particles are wetted by water. So this is only done for sulfide ores. And talking about electromagnetic separation, here magnetic property should be there. Magnetic property is there with the ores, then only we can separate. So here there will be a wheel like this, which will be continuously rotating. It will be rotating like this, right? It will be rotating, in which this wheel will be there. It is non-magnetic, whereas this wheel will be magnetic. And we put ore here like this, or we will add, it is like a funnel, and here we add what? Magnetic ore. Along with that, dust will be there, right? Dust means what? Gauge particles. So ore, as soon as falls here, comes here, comes here, comes here like this. Since ore is magnetic substance, ore should be magnetic substance, it attracts towards this magnetic wheel. It is magnetic wheel. So what happens, as it attracts, it falls near here only. So here we put a container. Since it is attracted to this magnetic wheel, it falls here. Whereas dust particles are non-magnetic, so these are not attracted by this magnet. So because of this fast movement of this, that dust particles will be separated like this, away from the magnetic wheel. This is how we separate dust and what? Ore, magnetic ore, right? So here we do it for iron ores. Iron means Fe ores like magnetite ore. We use what? This electromagnetic refining. Whereas other ore is there, hematite ore. The iron ore, other ore is hematite ore. To that we use gravity separation, hematite ore, because this hematite is not magnetic substance. So we use what? Gravity process, because hematite ore are heavier, they can be separated from the gauge particles. This magnetic separation is done for what? Iron ore like hematite, sorry, not magnetite, right? So froth flotation is for sulfide. And this leaching is done for those ores which are less reactive, like gold ore, silver ore, and this aluminum oxide also, Al2O3. What happened, man? Al2O3, aluminum oxide, we use what? Leaching. You may ask, sir, it is oxide ore, we should do this process. Which process? Gravity separation. But you are doing leaching. Why that is, sir? The reason behind this is, this aluminum oxide are less denser, means less heavy these are. So we can't have this gravity separation, because their ore particles and the gauge particles both cannot be separated by gravity separation. So we use leaching. So what is this leaching? The ore will be treated with suitable chemical reagent, right? Then it forms one compound which will be separated by filterization, whereas dust particles will not form the compound, so it will be separated out. Later on we will extract from that soluble product, we extract the pure ore, right? So if you want to see the example, the above one is the example. See here, aluminum is treated with a suitable reagent, that is sodium hydroxide. It is concentrated sodium hydroxide, it forms a compound, right? That compound again treated with water, it forms this PPT. During that, the dust particles remains as it is, right? So this is how we can separate them. Later on this will be heated, we will get a pure ore, which is aluminum oxide ore, right? So this is how. So the answer for this question is, leaching is the process for the given above reaction. Thank you.